The Mahanadi River drains a basin area of over 130,000 square kilometers, more than twice the size of Sri Lanka. For centuries, its waters would swell during the monsoon, sweeping away entire agrarian communities in the delta. In peak seasons, millions of cubic feet of water tore through the region with zero predictability. A single heavy rainfall upstream meant absolute devastation downstream. When India gained independence in 1947, the new government looked at the Mahanadi and saw a massive, untapped resource. They intended to capture that kinetic energy and put it to work for the entire region. Prime Minister Jawaharlal Nehru laid the first batch of concrete to authorize a barrier of staggering proportions. Constructing a dam of this magnitude tested the young nation's engineering capability to its absolute limits. They were attempting to physically command the geography of the subcontinent. To understand the scale of the Hirakud Dam, you have to look at the total span. The entire structure stretches across the valley for an astonishing 25.8 kilometers. Engineers built a 4.8-kilometer central concrete section between two hills, extending 21 kilometers of earthen dikes to seal off the low-lying saddles. As this fills in, the result is a colossal artificial lake covering 743 square kilometers. Holding back that much volume creates intense hydrostatic pressure. An ordinary foundation would be instantly pulverized by the force of the water trying to escape. The primary defense against structural failure relies on a carefully controlled array of 64 undersluice gates and 34 crest gates. When these gates open, millions of cubic feet of roaring water are released. If that flow crashes straight down, the sheer kinetic energy would erode the riverbed and completely undermine the dam's foundation. The spillway features an OG profile, a smoothly curved slope ending in an upturned ski jump bucket. Water flows down the curve, launching into the air and breaking apart mid-flight into a harmless spray, dissipating its destructive velocity before reaching the riverbed. While the spillways handle the excess, the rest of the flow is directed into massive hydroelectric power plants. Deep inside the Burla and Chiplima stations, specialized Kaplan and Francis turbines harness the current, generating up to 347.5 megawatts of electricity. By calibrating the sluice gates and the turbines, the system turned a terrifying natural force into the primary economic and agricultural engine for the state of Odisha. Operating a structure like this requires balancing a strict protocol known as the rule curve, a schedule that dictates exactly how high the water should be on any given day. It creates a constant tension. Engineers need to keep the water levels high to generate power and supply local industries, but they must keep the reservoir low enough to absorb sudden monsoon floods. This 2D cross-section reveals a creeping threat to that balance. Decades of silt and sediment have built up along the reservoir floor, permanently destroying 24% of the lake's original water-holding capacity. With less room to store water, late-season monsoons in 2008 and 2011 quickly overwhelmed the lake, forcing operators into emergency panic releases that inundated downstream districts. On top of that, hydrological estimates have been drastically revised. The dam was originally designed to handle a maximum flood of 42,450 cubic meters per second. Today, experts project that a superflood could hit 69,632 cubic meters per second. To secure the structure, the government initiated the Dam Rehabilitation Project, backed by the World Bank. Their solution involves physically cutting open a 945-meter section of the left earthen dike to create a massive emergency escape route. This topographic map reveals the exact path for a new additional spillway and 2.14-kilometer concrete spill channel. Acting as a bypass during a superflood, excess water is routed completely away from the main structure, discharging safely downstream. The Hirakud Dam is a continuously evolving machine. Through constant adaptation, engineers are ensuring that its legacy of protection and power will hold strong for generations to come.